Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of dilation representations. This is standard 8.3c in the great state of Texas, and we are using item number 20 off the 2021 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got this hexagon here, and it models the shape of a garden in a park. It's going to be dilated. All right, so remember when we dilate things, we are either going to grow it or we're going to shrink it with a scale factor. And vertex Q prime is going to be located at 21.7. It doesn't really matter, but I mean 21.7 is off our grid here, right? So if we wanted to kind of extend this, maybe 21 is around here. So 21.7 is going to be like right there. Q prime 21.7. So this Q right here, which is at originally it's at 6.2, is going to move over to 21.7. How we get it over there, well, we'll have to see. We've got our algebraic expressions here. We just need to use a little bit of reasoning here. Let's see what happens here. So let's start with f. So f, this xy, we need to replace it with our q. So we're just going to take all of these, we're going to put them as 6.2. So that's step one. We need to see what gets us to that 21.7. Okay, so we do a dilation here, but it's going to be this is going to be a shrinking dilation. I know that because the scale factor 2/7 is actually less than 1. When you're less than 1, you are going to shrink it. All right, so that's going to be by 2. And so let's see what we get here. This is going to be 12/7, and that's going to be 4/7. All right, so that's definitely much smaller, but that's not going to help me. My 12/7 is 1 5/7. That's about right. It's going to be like right there. Not really what we're looking for. It needs to end up over here at 21.7. So that shrunk it. Looks like I'm going to need to grow it if that's not going to work. Let's check G. All right, so that's a 6. That's a 2. All right, we're just going to add here. All right, so this is going to be a translation. So what this means is we're not growing it or shrinking it. We're just sliding it. We're just moving it along. 2 plus 5. Keep it the same size, keep it the same orientation. So that's going to be, oh, look at that, 21.7. You know, I'm going to question mark this. I don't think that's what we need to do, because this said it's going to be dilated, and that's not a dilation. This right here is a translation, because we're just adding to the x and y, which means we're just sliding it, right? We're just going to take this whole thing, and we're just going to kind of slide it up this way, but we're not growing it or shrinking it, but it specifically said dilated, so I'm going to keep working. I'm thinking, even though that does give me 21.7, thinking there's going to be a dilation. Well, H is definitely not going to work because it's another translation. It's just going negative now. So we've got this 6 minus 15, and then we've got this 2 minus 5. So that's going to be -9, -3. So that's way down here. But it is just another translation. We're just sliding it. Let's see what J looks like. Hope that's the answer. 6.2 we are. Okay, we're going to multiply it by something, so we're going to dilate it. Looks like it's going to grow because it's greater than 1, that scale factor, so we're going to get 7/2 times 6 and 7/2 times 2. That's kind of tricky here. So we're going to get 7 times 6 is 42 over 2. 7 times 2 is 14 over 2. That doesn't look right. But you know what? Those are improper fractions. Let's see what that reduces down to. Oh, 21.7. That's what I need. My answer is J.